Now we're live. So we want to talk about significant figures, often abbreviated sig figs for short. Sometimes it's called significant digits, and so you may hear sig digs, especially I think in Britain. But here in North America, we usually say sig figs. We want to start out with a rhetorical question. What's the difference between $600 and $599.87, besides the obvious, well, there's 13 cents difference? One value is more precise than the other. Scientifically, we say that one has more significant or relevant figures or digits than the other. There are rules for sig figs, but it's much easier if first I do a bunch of examples, have you spot the pattern, and then I'll give you the rules. 600 has one significant digit. $599.87 has 5. So we're going to start out just asking, hey, how many sig figs? The number 5, how many sig figs does it have? 1. What about the number 12? 2. What about 103? What about 130? That's got 2, and here's what we would be arguing. Acacia, we would say that last 0 is only a placeholder. Anytime the last digit is a 0, we assume that's a rounded off value or a guess. We assume that we measured 130 something. Can't be more than that. How many sig figs? 2. How many sig figs? 2. How many sig figs? Why 6? We would argue the only reason for putting a 1 right there is the instrument that I was using was that accurate, and there was actually a 1 there. Oh, sorry, 6. Jeez. 20, how many sig figs? 20 with a decimal, how many sig figs? Why? Well, let's suppose I was using an instrument that was accurate to 2 sig figs, and it just happened that that number that I measured was a 0, not a guess. This 0 is accurate. We show that by putting a decimal point after the 0 to say, I measured to that level of accuracy, and it was a 0. It wasn't 20-something. It was 20-point-something. What about for decimals? How many sig figs? 2. How many sig figs? Yep. How many sig figs? Also 3. Why? Why would I have added that 0 unless the instrument that I was using was accurate to this many decimal places and I just happened to measure a 0 as my value? It was 620, not 621, not 625, 620. This is 3 levels of sig figs. How many sig figs in N? 5. How many sig figs in O? 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs of accuracy, which in real life you would probably never get. Instruments just aren't made that accurate. Maybe at like the Large Hadron Collider in CERN or something like that. 20.00. How many sig figs? 4. The easiest way, Scott, to count sig figs is if they give you the number in scientific notation. You ignore the times 10 to the in your counting. How many sig figs? 3. How many sig figs? 4. How many sig figs? 5. If you want me to give that to you in English as rules, okay. First, any non-zero number counts. So 456, how many sig figs? 0.9723, how many sig figs? 4. Zeros to the left, that's that way, of a decimal point count. So how many sig figs for the top one? How many sig figs for the bottom one? How many sig figs for the top one? 3. How many sig figs for the bottom one? 2. Turn the page. Maddie, decimals are a little trickier. Zeros to the right of a decimal are tricky. If there are non-zero numbers to the left of the 0, they count. Otherwise, ignore. What? 67.00. How many sig figs? Not 2, but 4. 67.0001. 6. 0.00035. How many sig figs? 2. How many sig figs? 3. And how many sig figs? 4. See what I mean by it's easier just to spot the pattern than to try and give you an English rule? Just do a bunch of them. All right. So now that brings us to the rules for rounding off with science values, sig figs. There's a rule for multiplying and dividing, same rule. And then there's a rule for adding and subtracting. What's the rule for multiplying and dividing? Suppose I'm multiplying 6.74 times 2.0002. How many decimal places, where do I round off to? How many sig figs of accuracy can I go with? So here's the rule. This 6.74, how many sig figs? 3. Above it, right, a little tiny 3. 2.0002, how many sig figs? Above it, right, a little tiny 5. What's the smallest number that I just wrote? I'm going to go to 3 sig figs in my final answer. So when you're multiplying and dividing, you go to the smallest number of sig figs in your data. But you don't round off until the end. Everybody get your calculators out, please. Of course, you all have them out by now, don't you? Especially if you were foolish enough to arrive late. I'm not even listening. You type in the question exactly as they give you. You never round off before you go to your calculator. So 6.74 times 2.0002. And all of our calculators should say 13.481348. Unless you have your calculator in a weird mode. How many sig figs are we going to go with? So the 1 is the first sig fig. The 3 is the second sig fig. The third sig fig is the 4. Now, is that 4 going to stay a 4 or become a 5? How do you know? Next to it is a number 5 or bigger. So we look at that 4. That's where we're going to round off. Final answer, 13.5. It's the same rule for division. In B, 6.4, how many sig figs? 9.0088, how many sig figs? 4. I'm going to go to 2 sig figs. I'm going to go to my calculator. 6.4 divided by 9.088. and I get 0.7042. No. I'm going to go to 2 sig figs. The second sig fig, I guess, is that 0. Is that 0 going to stay a 0 or become a 1? And that's why sometimes you'll see a 0 at the end of a number or a decimal. We're saying that's how accurate we were. That's how many sig figs of accuracy. So, rule 1, never round off until all your calculations are finished. Don't round off. Type it into your calculator as is. Rule 2, smallest number of sig figs in your data. Can you try these 4 questions right here on your own? I'm going to do them. You can look up and see if we get the same answer really, really quickly. Is that what you got? Have you done Chem 11 before? This semester. So has Mr. Ferrugia done sig figs already? Yeah. The first unit we're going to have some overlap. So I got, for example 1, 75.43 sig figs. Example 2, 75, 2 sig figs. Example 3, 68, also 2 sig figs, but with different numbers. And example 4, I guess 1 sig fig, so I round off after the 7, but I can't just write 7, because on my calculator, clearly, it's 67.8. So if I just wrote that, no, it's 70, and that 0 is not considered significant. It's just a placeholder, Scott. It's bumping the 7 over and making it a 70. That's the rule for multiplying and dividing. The rule for adding and subtracting is tougher. It doesn't have anything to do with sig figs. It has a lot to do with decimal places. So for multiplying and dividing, count the sig figs. For adding and subtracting, Cole, count the decimal places. Cole, this 4.567, how many decimal places does this first number have? Psst. 3. Everybody beside that, write a little 3. 9.0, how many decimal places, that again. How many decimal places does 9.0 have, Cole? What's the smallest number I wrote? I'm going to final answer to 1 decimal place, not sig fig, decimal place. I'm going to type this into my calculator as is, 4.567 plus 9.0. Did typing the 0.0 make a difference to my calculation at all? No, so if you skipped that, fine. And I get 13.567, but Cole, how many decimal places am I going to go to? Where's the first decimal place? That 5. Is that 5 going to stay a 5 or become a 6? So, final answer, 13.6. Now, I want you to notice something. Sophie, 4 sig figs, 2 sig figs. How many sig figs is my final answer? 3. You'll notice it had nothing to do with sig figs. The rule for rounding with adding and subtracting, decimal places. Decimal places. And it's easy to get the multiplication rule mixed up with the addition subtraction rule. So rule 1, use all known digits in the calculation. Rule 2, round off to the last decimal place that both numbers have in common. In other words, round off to the fewest number of decimal places that everything has. So it's going to look something like this. Clody, this 19.324, how many decimal places does it have? Yes. Relative 3 there. 2.15, how many decimal places? Yep. 8.6789, how many decimal places? What's the smallest number you just wrote? We're going to go to 2 decimal places. Now again, 5 sig figs, 3 sig figs, 5 sig figs. I'm not counting sig figs, not for adding and subtracting. So Chloe and everyone, get your calculators out. You type it in exactly as written, 19.324 plus 2.15, take away 8.6789. I'm not going to write 12.795. How many decimal places did you say I'm going to go to, Clody? What's the second decimal place? The 9. Is that 9 going to stay a 9 or get bumped up? How do you know? You're right, because 5 are bigger. Now, if I bump this up, what's the 9 going to become? What's the 7 going to become? Does the 2 get bumped up as well? No, we stop there. So I guess it's going to be 12.80. Which has 4 sig figs, which doesn't appear anywhere in our data, but that's not the rule for adding and subtracting. It's not sig figs. And this you're going to kind of have to practice and memorize. There's a rule for multiplying and dividing. There's a rule for adding and subtracting. Is that okay? Fahim, let's do the next one together, you and I. Example 6, 25.6, Fahim, how many decimal places? How many decimal places in the next one? Ooh, how many decimal places? It's a trick question. How many decimal places am I going to go to? 0. Okay. 25.6 plus 13.79, take away 12. Fahim, what's my final answer if I round off properly using the rules for sig figs going to be? Yep. What if you wrote 27.0? I would have to mark that incorrect, because now you said you're accurate to 1 decimal place. We cannot say that with this data. Try the next 2 on your own. I'll do them up here. You can look up if you get stuck. Seven is a bit of a curveball. So if you look at number 7, can you all look up for a second? This 200 is really tricky because it doesn't go to 0 decimal places, because there's also a 0 here and a 0 here. This 200, I can only assume is accurate to the hundreds column. So now if we're talking decimal places, it's not exactly decimal places. Now I'm talking actual columns of numbers. The most accuracy that I can go to here is in the hundreds. So when I typed this into my calculator, 200 plus 80.7 plus 36.45, I can't go to no decimal places because these two zeros here tell me that those are guesses, that they are not significant. I can't be that accurate. I can only be accurate to that column. The 3 is sitting in that column. All I can say is 300. Very similar with example 8. With example 8, yeah, 2 decimal places, 3 decimal places, but this one here, instead of decimal places, Brendan, I really think to Braden, not Brendan. Braden, I really think to myself, I can only go to columns. I can only go to the third column, the hundreds column. So again, I type this into my calculator. As is. I get 409.628, but all I can be accurate to here is the 400s column. The best I can say here is 400. 1 sig fig of accuracy, or the hundreds column of accuracy. So if you want a summary, the rules for multiplication and division, fewest number of sig figs. Rule for addition and subtraction, least number of decimal places, or highest value column if you don't go very far. Fahim, is that okay? Colin, yeah? 7 and 8 are weird, I know. What's your homework? So if you haven't finished off the homework from scientific notation, you can. And then you can also work on this. Once again, the answers are attached to the very, very end at the end. So before you ask me if you've done it right, just turn the page and check if you've done it right. And as always, a candy if you find a mistake. Although I think this one might be good.